Okay, let's solve this example. We have x times quantity x plus 6 equals 2. Now, sometimes people get stuck and just don't know how to proceed at all with this kind of thing. One thing you definitely cannot do is set each one of these terms equal to 2. That only works when you have 0 over here. So don't make that mistake. I would say it's a trap. Don't do it. Instead, think of it this way. I always say x squared likes to be set equal to 0. So if you can see enough of this to tell that this is really x squared, then if you remember that x squared likes to be set equal to 0, you'll know how to proceed. Otherwise, you could get tangled up in this and not know how to proceed at all. Okay, so let's do it. Let's multiply this x through. We have x squared plus 6x equals 2. And again, x squared likes to be set equal to 0, so let's do x squared plus 6x minus 2 equals 0. Okay, now we see that this is a quadratic equation, right? We can get our a, b, and c. We have nothing here, so this is our a. Our b is 6, and our c here is negative 2. Okay, because remember, these are of the form ax squared plus bx plus c equals 0. Okay, once we've identified these, we're ready for the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So from here, we just plug everything in. If we do it carefully, we'll get the correct answer. Let's see what we get. We have x equals negative b, so negative 6 plus or minus the square root of, okay, b squared, so 6 squared, minus 4 times a, which is 1, times c, which is negative 2, all over 2a, 2 times 1. All right, so negative 6, let's just clean this up a little bit. 6 squared is 36, negative 4 times negative 2 is 8, so negative 36 plus 8, all over 2. Negative 6 plus or minus, I'm thinking that comes to 44, all over 2. We can simplify square root of 44, right? Because 44 is actually 4 times 11, and the 4 pops out as a 2 because square root of 4 is 2. Okay, so then we have negative 6 plus or minus 2 rad 11 over 2. Well, let's divide each one of these by 2. When you have a single 2 in the denominator like this, you need to make sure it divides both of them. You wouldn't just want to cancel it with this 1 2, this 2 on the top and call it good. You need to divide both of these by the 2. Okay, so let's see here. So that gives us negative 3 plus or minus rad 11. There we go. And note that this is really two different solutions. We have negative 3 plus rad 11 and x equals negative 3 minus rad 11. As a shorthand, we use this plus or minus. Let's try another one. For this example, we have quantity p minus 1/2 squared equals p over 2. And again, upon first seeing this problem, it might be hard to see how to proceed. The one thing, if you can just notice that this is actually a p squared problem. I know that's hard to see, but p squared on one side means we have to have a bunch of stuff and then equal 0 on the other. Anytime you have your variable squared, think equal 0 on the other side. So that might be a little hard to pick out, but that is certainly how to view this problem. Let's go ahead and square this out. I'm going to use the binomial squared formula to expand these parentheses here. So that gives us p squared minus 2 times p times 1/2 plus 1/2 squared equals p over 2. We can simplify that down. P squared minus p plus 1/4 equals p over 2. And before I go any further, we don't want to get tangled up with doing quadratic formula on fractions. And this is heading down that path. Really, any kind of trinomial, it's best to get rid of the fractions. when you have an equal sign involved. When you don't have an equal sign, you're stuck with the fractions. Here we do have an equal sign, so I'm going to get rid of it by clearing fractions. What can we multiply both sides by to get rid of all these fractions? Well, it's the LCD, and it happens to be 4. So 4 and 4 like that. What does that do for us? Well, that gives us 4p squared minus 4p plus 1 equals 2p. And now, remembering that p squared likes to be set equal to 0, let's get that 0 on the right side here. So we'll subtract 2p from both sides. 4p squared minus 6p plus 1 equals 0. Okay, now we're ready for the quadratic formula, and we can see that this 4 here is a, negative 6 here is b, and plus 1 is c. So here's the formula. Okay, and hopefully you could rattle this off from memory. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's just plug in there and see what we get. In this case, it's not x equals, it's going to be p equals. You just take whatever your variable is. All right, negative b, so negative 6 plus or minus the square root of b squared, so that'll be negative 6 squared minus 4 times a in this case is 4, times c in this case is 1. All right, all over 2 times a, 2 times 4. Simplifying this down gives negative times negative is positive 6, plus or minus square root of negative 6 squared is 36, minus 4 times 4 is 16, all over 8. Okay, so we have 6 plus or minus rad 20 over 8. Okay, 6 plus or minus, now rad 20, right, we can think of that as rad 4 times 5. I'm looking for perfect squares that are factors of 20. 4 is a perfect square, and it pops out as a 2. So this becomes 6 plus or minus 2. What's left behind? Rad 5 over 8. And then we can still simplify this. Here we want to take the 8 through to both of these terms, right? So let's do that. We have 6 over 8 plus or minus 2 rad 5 over 8. And we can simplify this to get, let's see here, we can get these canceled, 3 and a 4 left. Here the 2's cancel, leaving a 4 behind. So we can think of this as 3 plus or minus rad 5 all over 4. So really that's 2 answers for the price of 1. Let's try another one. Here's an example in which we want to use the quadratic formula to solve 2 equals negative 9x squared minus x. Now, before we use the quadratic formula, we have to get it into the right form for a quadratic equation, which is this, ax squared plus bx plus c equals 0. You want to have all the stuff on one side and a 0 on the other side. So let's work on that. Now, here's an important point. My personal preference, I like to have a be positive if possible. It's not even necessary. You'll get the same answer no matter what. But I just like to have my leading coefficient be on the positive side. I guess it's just part of my habits. So I'm going to do that. I'm going to add all of this here. So I'm going to add plus 9x squared plus x to both sides. Plus 9x squared plus x. And get everything on the left side there. So that gives us 9x squared plus x plus 2 equals 0. And now we are in the correct form for a quadratic formula. This is now a quadratic equation that is ready for the quadratic formula. So this 9 here is my a. Well, there's nothing here. Well, remember it's a 1 there, that's the b, and then 2 is the c. Okay, so we get our quadratic formula ready. Okay, there it is, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Memorize that. And we plug it in. Okay, so plugging into that, we get the following. Let's see what happens. So negative b, so that gives us negative 1 plus or minus the square root of b squared. Well, 1 squared is just 1 minus 4 times a, which is 9, times c, which is 2. all over 2a, which is 9. Okay, so now we just need to cook this thing down. Let's see, -1 plus or minus the square root of 1 minus, well, let's see, 4 times 9 is 36, times 2 is 72. So 1 minus 72 all over 18. So that gives us -1 plus or minus the square root of -71, there we go, over 18. Well, this negative inside the radical is going to come out as an I. Okay, so that leaves us with, and I'm going to break it up because we want our answers in a plus bi form. We don't want some denominator below both of those. These, you can kind of think of these as separate, completely separate. Okay, so let's break it up. That gives us -1/18 plus I rad 71 over 18. And there we are in a plus bi form.